make a little quick stream here to talk about some of the resources that I see out there in the data science world that are particularly helpful, for me at least. The kinds of questions I get from students all the time who are trying to go into the machine learning space or into data science in general, they don't really know where to start, and that's fair. Knowing where to start it's such a challenge in data science because it's such a wide field. And do you want to start with digital image processing, for example, or do you want to start with natural language processing? Do you want to go into econometrics, financial analytics? Like, where what is your entry point? I think what people don't really realize, what maybe some people don't realize is that in general, data science is the abstraction of science and analysis. So you'll often want to bring in your domain knowledge. And maybe an example of this is if you are coming from an English and composition or creative writing background like that, you might want to consider the analysis and structure of writing as one of the channels into data science as a whole. Maybe that can be maybe a little bit of a stretch. I think it's less of a stretch to say, well, you're coming from math, you're coming from physics, or you're coming from computer science, and you can consider certain types of problems where it's going to be helpful to have some kind of predictive analysis. Some packets are coming through, some router packets are coming through, for example, in computer science or in IT, and you want to be able to discern from their headers or payloads whether or not they're malware, right? That becomes a machine learning or a data science problem. So that said, I'm going to point at some resources that I personally think are very helpful. So right now we're looking at Archive. Archive is a place to get excited, I would say. And let's just say archive.org. I'm going to search archive.org, and maybe I'm interested in thermal images, so thermal, RGB, and convolutional neural nets. And it turns out I am interested in this in real life. Oh, no results. Okay, well, let's pare that down a little bit. Let's go thermal RGB and see what. Okay. Unraveling the unusually curved X-ray spectrum of RGB, etc. So we've got a couple pages of stuff here that looks awesome, probably. Don't know offhand. And, Archive just has massive amounts of published work, So multitask-driven feature models for thermal infrared tracking. Could be cool. Might be really hard to understand, So I wouldn't say Archive is a place to start, but Archive is a place to get excited. Like we can start looking at these things, and basically anything in, I'm not going to say anything, but a lot of things in math, physics, machine learning, data science, computer science. If you just search archive.org, let Google do that search for you. I don't really trust Archive search. Their information retrieval is a bit weak, but yeah, just archive.org space whatever you're looking for. Let's look. LSTM, right? Should get a lot of pages, so like 5 pages. Self-driving car steering angle prediction based on image recognition. And, you know, in the abstract, we can see that they're using transfer learning, a 3D CNN, LSTMs, and ResNet. So pretty cool. Now, in terms of where to start, I'm always going to recommend that you start, because I'm the designer of this thing, that you start with this DSI basic prep at Galvanize. You know, we've got a Python course here that's free, and it gets you to a rudimentary, you know, just above rudimentary level in Python. You know, the way that you become a good programmer is programming all the time. You solve your problems with code. That's how you get there. Similarly, if you want to become a good writer, you know, write a lot. If you want to be able to draw well, paint a lot, draw a lot. You can read about Python all the time, but you want to end up writing code. But what I would say, we've got this basic prep, and you know, registration's pretty quick. You have to give a little bit of information. You don't have to be interested in the data science immersive. Let me just say that. I'm part of this data science immersive. I work at Galvanize, but I think this course, I mean, we built this course to be complete and comprehensive for the foundations in Python. And we're constantly updating it, constantly extending it. So, you know, I would say go here, learn all the basics in Python. That's one of your fundamental things when you're going into data science. You're probably going to want to use Python, right? You're probably going to want to use Python. You can also use R. R is great. I really like it. You can get into, you know, Spark, you know, Spark ML. You know, there's a lot of different avenues, you know, but yeah, I would recommend Python. It's widely deployed, and it's an easy language to learn. So yeah, learn Python. A second resource, and I wish we're building this out in, you know, locally, but another thing you want to learn is you want to learn math through calculus 2, I would say. You're going to ultimately want to learn much further beyond that, but your baseline of knowledge should be, you know, fundamental mathematics through calculus 2. And I don't really know of anything much better than Khan Academy for that. So Khan Academy has both the level of calculus that you want to get through, and then I would say linear algebra. You know, Khan Academy has some linear algebra, and it's okay. But in that case, I would actually recommend finding maybe an MIT class. Well, no, I wouldn't say that. If you Google Udemy linear algebra, let's just do that. Why don't we do that? Udemy linear algebra with Python, let's say. Yeah, here we go. So here's a course. This is implemented in MATLAB and Python. And I would say, yeah, I'm familiar with this course, actually. This is good. There's a lot of Jupyter notebooks, you know, and those Jupyter notebooks have a bunch of ports of MATLAB code. So the class is generally taught in MATLAB with some demos in Python, but you're going to want to learn linear algebra. So these are the foundations, right? So we're thinking, you know, you need to know Python, you need to know how to program, right? And that's probably where you want to start. You need to have like some quantitative proficiency. I think you can get that through Khan Academy. You know, go through, you know, do their stats materials. Their stats materials are pretty good. You know, they're not, they have stats materials that are sufficient in terms of learning the distributions, you know, learning the fundamental stats that you need to know for those distributions. And then they've got through Calc 2, You know, you need to know, um, yeah, you need to know how to integrate, and uh, even better, multivariable calculus. You know, um, that's get into diffie-qs. You know, and honestly, if you're looking at going into data science, that quantitative literacy needs to be pretty good, right? Um, you can be coming from even a software dev, background, and not have that kind of quantitative literacy, and you need to build it in order to understand papers on archive.org, or to understand some of the things I'm about to show you, just the materials that are present out there in the world. So I would say that calculus, linear algebra, and basic statistics, like the equivalent of a couple semesters of statistics at a university level. And then there is an amazing site for learning your foundational distributions, and really a lot more than that, and that's JB Statistics. So we have, Galvanize has a lot of materials as well, and we're constantly building those out. We cover a lot of what is in here in this discrete and continuous probability distributions, but we don't have lectures up for them, and this person has great lectures. I would say if you want to learn this stuff, get on here, go through these videos, at least these two sections, sections 1 and 2, and even look at sampling distributions, look at confidence intervals, look at hypothesis testing, inference, like chi-square tests. Like all of this stuff is, comes back around when you're in a data science immersive, or if you're trying to self-teach. This is stuff that you need to have you need to at least know how to look it up really quick and implement it really quick, but you should really just know it offhand. So, ANOVA, regression. This regression section's really nice if you want to have some more theoretical underpinnings and you haven't really done much with regression at this point. Yeah, so JB Statistics is awesome. So let's say you've got that stats knowledge and you've got that quantitative literacy and you're pretty good with Python. If you ask me what would be your next step, I would say go to SKlearn. So scikit-learn is, I think of it as a kind of educationally oriented machine learning library, right? So, we've got scikit-learn. At this point, I'm assuming you've got Python installed. You've got, a lot of the things that you need, that you want, the tools, right? You know how to use a Jupyter Notebook. You know how to use VS Code or Atom, or whatever text editor you're using, and you know how to run Python just generally. The great thing about scikit-learn is, so what I would actually do is Google sklearn supervised learning, and this is a page dedicated to the types of supervised learning, or a lot of the types of supervised learning that are included in the scikit-learn library. So, linear models, Bayesian regression, regression, discriminant analysis, support vector machines. Like these are classic, and you need to know them. And then kind of these primers in gradient descent, and then neighbors algorithms, and naive Bayes. These are sort of core to what you need to know. There's a few of these that maybe you would never use, or maybe you would, if you're generally solving problems, you might use one or two of these. But you kind of need to know all of them if you want. Well, let's say you need to know something about all of them. Okay. So yeah, supervised learning, and if you click through, well, let's just look at ordinary least squares. This is pretty great. They give you a very short, right, short explanation. Um, if you want to know more about this, like why not just go to YouTube and look up, linear regression, ordinary least squares, and find a 20-minute, 30-minute lecture, right? If you're self-teaching, if you're prepping for an immersive, that's kind of the way to do it, right? And you pick from this and you go to there, and you pick from this and you go to there. So what's great about this is, from sklearn, import linear model, right? You've got this sample code. And, in this case, they're generating this data, offhand. And they are getting the regularization coefficients out of it. And cool. So they've got, when you look at this, they've got code, little code snippets for all of these. And beyond that, the other thing so that's supervised learning. The other thing you could do is go sklearn and go unsupervised learning. And again, start at the top, and read your way through. Try all these things out in notebooks or, in your code editor. And, make flashcards. I don't know, and mind you, this gets you a high-level view. You don't necessarily see how these algorithms are implemented, but here's something really awesome that I'm just going to point out. So sklearn, let's do ordinary least squares, and let's go to GitHub, and let's see if we can just get that. How about we just go to sklearn's GitHub? This is what I usually do. So sklearn GitHub, click on sklearn, wait for it to load with my somewhat slow connection at the moment. And then, this is pretty well organized, and the code base is really readable. So let's go to linear model, and let me make sure that that's where we actually want to go. Let's find out. So from sklearn, import linear model. This is our quote-unquote ordinary least squares. And when we're looking at this, where are we? We are in sklearn linear model. And I believe it's in base pi. Am I right about that? Linear, what was it? It was just linear underscore regression. No, linear camel case regression. Yeah, so here's the class. If you want to actually read through the code that that you use to build, this model, it's all right here. And the doc strings are great, right? So, look at this. This is kind of everything you need to know in order to use it. And also, you see, once you learn object-oriented object-oriented programming in Python, you've got, some skill base to be able to read this. Now, something to consider here is that a lot of these are going to be dependent on other classes, and you'll find that throughout this, that you're going to be pulling in functions or pulling in other classes. So you kind of have to jump around within the code base if you want to take this approach to learning. Often, though, you can find kind of the meat of the algorithm, right? And once you get a sense of maybe the coding culture and the types of semantics that sklearn uses, all of this will start clicking. Now, here's something here's something to consider though. This may, if this is too much of a jump, right? If your Python isn't strong enough, you might want to first dig into Numpy. Numpy is your, let's say, your massive matrix operation data structure, right? So they're like lists, but way better. You could go to numpy.org, and actually, the Numpy has fairly good documentation. But if you're just getting started, you might want to go to Kaggle, and they have a Numpy tutorial. I wish we could point you in-house at Galvanize. We don't have this material written yet. Like we have it for the DSI, for the actual immersive, but we don't have public-facing tutorials for Numpy or for Pandas at this point. It's all in development, and at a later time, I would point you there. But yeah, the Numpy tutorial for Kaggle is great, so that's a good place to start. And then, it's just here somewhere. Huh. Oh, it's just taking forever to load. Oh yeah, this is just this is in the form of a notebook. You can just learn how NumPy works, and NumPy is kind of a dream. It's really fast and makes a lot of sense. So you've got a NumPy tutorial that you could do. You could do a Pandas tutorial. Both of these are pretty requisite. Pandas is the main technology that you use to clean data, or can be, right? So Pandas, they've got this Pandas Kaggle tutorial here. I think there's a I think what I just showed you for NumPy was not great, so I think there's one of the, nope, yeah, There is some other NumPy tutorial that I thought was on Kaggle. I might be wrong. At any rate, you need to learn NumPy at some point, and if you want to go through the SKlearn code base, you probably want to learn NumPy. Pandas, this is more geared toward reading in data, looking, being able to analyze it. It sort of like gives you an Excel spreadsheet on steroids, right? And you can procedurally clean your data. You can do all kinds of stuff with it. So I would say this is a really good thing to do as well. So NumPy, Pandas, SKlearn, and between those, you've already built out kind of a pretty good knowledge base, right? To be able to start learning data science, really start learning it, whether that's in an immersive or you're going to self-study. If you've got a strong enough background to be able to self-study effectively, or enough motivation, right? So a couple other things that I'm going to point out. Let's say you want to go into natural language processing. There is another kind of educational library, nltk.org, and they have this book. So nltk.org/book takes you back to 1997 in terms of their aesthetic. That said, this gives you a foundation for analyzing text through using the NLTK library. NLTK is pretty good. You might want to go the route of Spacey, or there's other approaches to natural language processing. You might want to write all your own stuff, but this gives you a foundation in NLTK, which is the Natural Language Toolkit. And if we go to the top page for this, they give you some quick code examples here. And yeah, so that's sort of the NLP, natural language processing route. If you want to build out your foundations, I really recommend that book, nltk.org/book. And if you want to build a foundation in, let's say, in image processing, you plan to be working with a lot of images, there's a couple places to go. I recommend people start with scikit-image, so SKimage, and yeah, we'll just go to the main page of this. So SKimage is just one library, and they kind of take a similar approach as to scikit-learn in the way that they structure this. So pretty transparent. You can get on the GitHub. You can see how the underlying code for how images are manipulated. They've got some documentation. Their documentation's good. Let me say that. They've got a ton of examples. Like let's say, oh gosh, let's look at some examples. Let's look at the gallery. If you want to, let me just find something that's, yeah, like a convex hole. If you want to, if you see what this operation's doing, it's drawing the inclusive, the inclusion of this horse, but with these straight lines, semi-straight lines, I guess. So, they give you this, and in this case, I think they are, this is an image that they're pulling in from, SKimage import data. Images float, so you've got this float valued image that is data.horse, right? Loads this image with the horse function. But you could instead import an image, right? And do this with any image that you have. So in a lot of ways, SKimage is super accessible, right? Because you can take their examples and replace their images with your images and start tweaking the parameters of functions and end up with really interesting results. And you can learn a lot really quickly with just these examples that they have present. There are a lot of functions that there's a lot of types of functionality that you might want that are not in their examples, but in that case, my recommendation, and this is sort of maybe a antiquated old school recommendation, if you want to get into digital image processing for real, there's a book by Gonzalez and Wood. Let's see, digital image processing, right? So Gonzalez and Wood's digital image processing. Yeah, this looks like a recent version of it. This book, it's in MATLAB, but MATLAB and Python are not that different from each other. I think you can interpret somewhat between them if you are good enough with Python, or have a background in MATLAB. So this is a way forward if you're interested. I really like this book, and there's an accompanying book, or there used to be, because I never used I think I used the 3rd edition. So there's digital image processing, and then that's mostly theory, very little in the way of code. So you would have to use something like SKimage or the other library I'm about to show you, which is OpenCV. You would have to use one of those to approach, manipulating images through this theoretical lens. There's also digital image processing with MATLAB that is an accompanying workbook for this book, and that has a ton of code. It's all MATLAB code, and if you search on GitHub, you can find people's repos where they have written Python that accompanies the chapters of these books. Maybe not for the 4th edition. This is from 2018, so I kind of doubt it. But definitely for the 3rd edition, I have seen repos on GitHub that cover large amounts of this material. So you're not totally in the dark. You're not totally writing all your code from scratch if you want to use other people's resources. Although great learning experience, right? Write that code from scratch. So the other, and this is more common, OpenCV. So OpenCV is, well, you can read the description of it. It's a massive image processing library, and it does have documentation. It has, this really beautiful page for documentation. Um, and notice these are all zip files. Cool. Okay. Yeah. No one is doing that. Um, yeah. I would say that there is a somewhat of a barrier to entry with OpenCV. However, you know, you can go to courses and you can work your way through, their actual courses. Um, I wouldn't recommend that. I would say start with SKimage and then um, find people's blog posts and start playing around with OpenCV and reference the documentation um, and go back and forth that way. OpenCV, like I said, it is more standard, and if you're getting into digital image processing, it's probably the better way to go. But if you want to begin learning, I would say SKimage is golden. I love SKimage. I use it all the time. But there are times where I use OpenCV as well. Maybe not solely though. It's usually in pre-processing of images for going into a neural net or going some other operation. So it's usually some huge batch process that I'm performing. So that's kind of yeah. That's I'm sure there are other I'm sure there are a lot of other places where you could go. I'm gonna just peek at the channel really quick and see if anybody asks any questions. In all likelihood, nobody is watching, so that's fine. Maybe nobody asked me a question. This is not not one of my. I'm mostly doing this stream just to test how this integrates with YouTube, So I just took the opportunity to talk about some stuff. Oh gosh, it's me, Inception. Cool. All right, that is all. That is all that I'm thinking about right now. And I'm gonna go ahead and see. Oh, one last thing. There is a book that if you're feeling pretty good about Python, if you are if you're feeling pretty good about Python and you want to learn how neural nets function kind of on a foundational level, there's an author named Sebastian Raster. Python Machine Learning. This book, this is good. It's really good. And I think they're on the, third edition, maybe at this point? That seems probable. So notice there is a GitHub account, or this isn't even him. This is someone else's repo on him, I believe. But yeah, if you go to sebastianraster.com, he's got an excellent blog. He covers a lot of things in that blog. This is from December actually, December 2019. Yeah, so I at some point went through the second edition of this book, and I'm not sure what's new in the third edition, except for TensorFlow 2, right? Is that what's going on here? And and a chapter on GANs, which are super fun. They're they're super fun. Yeah, and if you're trying to get your Python chops up, let's say you're in your beginning stages of Python, let me just back up. I recommend this book. I think it's great. I think it gives you a good foundation from a good mathematical, and if your math is already pretty good and you want to understand, foundationally how a lot of these algorithms work, and you want to be able to code them from scratch, and you want to be able to use the libraries, the tools that already exist out there, which you do. You probably don't want to do this stuff from scratch ultimately. Then this book is great. It is probably my favorite at this point. Although I haven't read the third edition, I'm sure it's great. So one last thing, if you are trying to get your Python chops up, you just need practice. I would say, go to Code Wars and, train Python. Train Python on Code Wars. If you're relatively new, or you're just trying to knock out things really quick, you can limit to 7Q. The way this works is 8Q is the easiest. 7Q is, slightly more difficult. It's all arbitrary. It's all based on either where the community puts it or where the author of the problem puts it. So maybe you want to do 8 and 7Q problems, and the way that I avoid kind of badly written problems is I go to well, I'll set this to Python first. So I'll go to Python, and I'll go to popularity. And I tutor out of this a lot, so if I just need a problem to work through with somebody, to try to give them this sense that they can just solve problems, then we go here and pick a problem and work on it. Yeah. A lot of the 8Q problems I just wouldn't bother with, though. I would start at 7Q if you have rudimentary Python knowledge, And a lot of these are, the problems are pretty simple, but reps, right? This doesn't necessarily teach you how to be creative with your coding, but it does show you, it does get you to the point where you don't have to look up simple things anymore. So in this one, given a string of words, return the length of the shortest word. Strings will never be empty, blah, blah, blah. Yeah. So that's for getting your chops up after you learn your foundations. And yeah, hopefully this will be helpful to somebody if you're trying to get into the space, or you're trying to figure out what to look at, what to study, what to play around with. Let me see if I can recap what we talked about. Learn Python. Get your quantitative skills through calculus and through linear algebra, and through stats, sort of like foundational stats. Then, you'll probably want to learn Numpy. You'll probably want to learn pandas, and then start going through all the SKlearn supervised and then unsupervised learning stuff. Their documentation. If you want to get into natural language processing, nltk.org/book. If you want to get into digital image processing, start with scikit image, and see what you can do there. OpenCV is also there. There's the book Digital Image Processing by Gonzalez and Woods, which is great. It is like the book. And then Sebastian Raster's Python Machine Learning is an excellent primer into that space, and I think, and his blog is great. Oh, yeah, there's and if you're looking for podcasts, there's TWIML, TWIML, which is This Week in Machine Learning. Let me see if I can TWIML. This Week in Machine Learning. There's also apparently a markup language called Twiml. So yeah, the Twiml AI podcast is, you know, go there, listen to it. It'll, maybe some of it'll be open over your head. A lot of it's pretty accessible though. They talk about really cool problems. So um, yeah, this is the one that I like the most. Although to be honest, when I listen to machine learning and data science podcasts, they all sort of blend together in my head. So you know, there's others, and they're easy enough to find. Just Google machine learning podcasts. Um, the Wanted to say one more thing. There are some great blogs for kind of the, how do I say this? There are some great blogs out there that will give you understandings of foundational concepts like cross validation, uh, you know, and then of course Stack Overflow. There's some of the best explanations of algorithms or things like that. You're just going to find them on Stack Exchange, Stack Overflow. And then I think that I had one other thought, and I can probably just save it because I'll likely do a more structured stream about this sort of thing later. You know, um, I think I might even do some streams around, um, exploring those algorithms on SKlearn. Just to give a hands-on, like how would you do this for yourself if you're trying to learn these things. Um, maybe we'll even do some walkthroughs of some of the stuff in Sebastian Raster's books, because I think his forward and back propagation explanations and math are great. So like the way he does it is very teachable and very learnable. So we might do that at some point in the future. Yeah, and in the long run, my goal is to do a somewhat structured, somewhat self-guiding, right? Like, or audience-guided show, exploring data sets and doing that twice a week on a regular schedule, and then having guest people come in and demo things. A lot of this is meant to be accessible for people who are going through our Galvanize Learn materials, our Galvanize preparatory materials. They're all in a Slack channel. They can ask questions in there, and my intent is to post when these shows go live, so people can jump in and ask questions live. And as I'm exploring some data set, like I'll go find some new relevant data set that I've never seen, start walking through it, ask you guys for help. If all of that sounds good, let me know. If you have other ideas for what the data is data stream would look like as a regular show, a couple times a week for 2 to 3 hours, let me know. Send me a message. Tell me what you think. And all that said, thank you. And I will, until I get all that stuff formalized, I'm just going to be on here intermittently, making instructional videos or, for that get embedded into our product, or just talking about random things that I think are cool, that, or things that I think will be helpful for new people new to the data science and machine learning spaces. So that's all I got. I'm Tobio. Bye.